Yes, so I'm working on the Recreate project, and it's also part of my doctoral studies. And the aim of Recreate is to close the loop for precast concrete and towards a circular economy. And this is an image of our construction pilot last year in Helsingborg. And the focus of this presentation will be on logistics, but there are many other aspects to consider when it comes to reuse of buildings. And this is also a timely and a relevant objective relating to the transition pathway for construction from the European Commission regarding environmental assessment of buildings, regarding digital product passports, regarding traceability of where these elements come from, since there are a lot of policies aiming to enable reuse. And when it comes to reuse, we also need both tracking and tracing. Tracking usually refers to knowing the type and the number of elements, where they are located, and when they will become available. While tracing is important to know information on previous life cycles, the ownership and the lifespan of materials, and specifically regarding concrete, the condition of panels, and the location history, which can be useful for some of LCA modules. Usually companies don't have a model-based approach towards tracking, but they have some internal processes which they use, which they need also to comply at the country or at the European label. So they have some identification number, and they mainly use an internal database or some existing tools like a spreadsheet or some other tools which can be shared or used for collaboration. While this is prone to error because it's not an automatic identification through the database, while if we integrate and use digital technologies with a database, we can automatically identify the element in the database, and also use a small transfer of data either in the tag itself or in the database. So also the tag can be used to store some information. There's a wide range of technologies. So the simple one that used to be used also in these Swedish buildings in the 1960s is a stamp or a metal plate, which is still in place today and is still readable. And there's a lot of other technologies that are like Bluetooth or RFID. RFID is radio frequency identification. The difference between passive and active is in the use of batteries, and also the range changes. Then there's near field communication, which is a subset of RFID. This has not yet been used for tracking elements. There's QR codes, which there's some work going on QR codes, either on blockchain or for placing it on elements. And there's barcodes, which is the most simple. And QR codes can also be static or dynamic. And the use in construction has mainly focused on using RFID in new construction or for prefabrication. And while NFC, which is a subset of the RFID and also provides secure communication and transactions, can be easily found in credit cards and so on, this has not yet been applied to elements. So this is something that we're looking at. And from a bibliometric analysis, we can also clearly see that the focus has been on keywords like RFID, or the full term radio frequency identification, Internet of Things, blockchain, supply chain, while these other technologies are missing or don't come up in this high-level analysis. Maybe you're familiar with RFID, but very briefly consists of three components: a transponder, the tag, transceiver, the reader, and antennas. And it also requires a software application and equipment. So it cannot be used with mobile phones. It can also read automatically a lot of elements at the same time. And briefly to show how is RFID, so it can be a printed tag or laminated tag to protect it from weathering, or encapsulated rag tags. These are most commonly used in concrete, for example, because it's in alkaline environment, which would damage, and this is mainly used to protect the tag. And as I said before, the focus has been on new prefabricated construction, for example, in Hong Kong Housing Authority and researchers, and there's several papers since 2015 in automation in construction, mainly focused on RFID and how they're using RFID on this topic. There's also some very new interesting developments in Bluetooth that we also explored in this paper, and although these are not yet adapted to construction, they could be used also in construction because they would enable a decentralized or use of and sharing of this material and elements, not structural, but also structural, and also for tracking them using mobile phones and without using antennas. So the whole idea of this initial work that we are presenting in the paper is to have the physical element before the deconstruction, or at some point put it in a database and use of mobile phones, and also link it to a BIM application. So the first question is, which has not been seen in other research, is that they mainly use it on new construction and then the building is there. While in this case is how do we align which technology apply to which life cycle, because the sides of the panels, once the building is constructed, they are not more visible. The surface is visible when the element is constructed. Then when it gets deconstructed, these elements are again stacked, so the surface is not yet visible. And then they get, again, reassembled into a new structure. These are images from the construction pilot. So in the paper, we propose a new digital workflow. We are using a phase-based Revit family to model the tag and put it in a template or in the model. There are two ways. It could be either model the tag or as a property on the BIM model. This is something that is a choice, that we are not suggesting one is better than the other, but of course if you have a specific condition from the use or from the existing condition, then we of course need a more precise location where that element is, either in the type of the panel or either in the condition. And then we place an NFC, so the near field communication and a Bluetooth tag together or separately in the surface of the panel. Then when these are stacked, a QR code could be attached to have this identification. And then when the elements are reassembled, the higher cost Bluetooth could be recovered, and the NFC could be left for life cycle tracking to have in the existing condition, and also to share information with users to know sustainability aspects of their own building. But this would also require a role-based access to levels of information. What can be seen publicly, what can be seen by users, and what can be edited. So in the integration mainly explores these three technologies, QR codes, Bluetooth, and NFC, through the use of mobile devices, storing a database which has an image, a location, and the identification of these tags, and also perhaps using a 3D model like Speckle with things annotations that we need on the site, or store them directly on the database, and also transfer this information into the BIM model. There are different element IDs that come into play, and there's the Revit element ID, for example. Each BIM tool has its own, IFC GUID, or there's the global trade item number system, and there's the digital product password, which is being defined and being developed. So every ID plays its own role, and but there's also one ID that we have proposed and we are developed to track elements, so that is independent from this, or it could be related to this. This is something to be discussed further, because a lot of things are being developed currently. And why do we need a model-based instead of drawings? A lot of companies still use existing drawings, but also still today, to tag the elements or the materials, while we are moving more towards a model-based construction or deconstruction. So it makes sense to have these elements placed in a digital model and be able to also have this integration of tags in the model. So we did some laboratory examples to test these technologies. Now you cannot see because I put a PDF, but we did some core drills and at different depths where we placed an NFC tag, simple NFC tags that can be bought on Amazon, and then also that's also the correct size to place a Chipolo Bluetooth tag. And as you can see, also pouring concrete without rugging the NFC, and we had some very positive results, because even without rugging, the NFC was readable. And these are the 5 scenarios that we tested, so encapsulating the NFC between 2 acrylic 3D printed layers, pouring a lightweight concrete at 2 different depths, just placing the NFC on the concrete surface, or combining the NFC with the Bluetooth. And we tested it with the 2 devices, the reading capabilities. Then, yes, this video will show the reading capability for the NFC through different architectural surfaces, because the concrete is not the final surface, and also testing of the QR codes, which should forward to a web page. These are the test results of different architectural surfaces. So the first column reports the base depth where the NFC is placed, and then the other columns report the different surfaces. So for carpets or for wall surfaces like linoleum, ceramic tiles, different depths of carpet, plywood board, and hardwood wood board. And only in the last column, we did not have a reading capability of this NFC, but there's also NFCs that have higher reading capability, which could allow for this. Using QR codes to generate these elements that integrate, which are very easy placeable, have low cost, and they could also, when the element is cut, be easily substituted, and that would just be an addition to the naming convention that we are using. 3D viewer, and this is the Bluetooth app, so these are not adapted to construction, and it's going to give me some messages like you have left your wall behind in this case, which is not exactly what we need. And then the NFC, we can store a lot of information in the NFC, but we can also link it through a database or through a web page. Managing access, this is again, in this case, using existing tools like Microsoft SharePoint and Microsoft Lists. And the NFC introduced a wayfinding mark last year. And so these are some impressions how it would look like, and we are planning in our upcoming construction pilot to integrate these things. And also the NFC forum is also looking at extending the ranges or extending the range of the reading range of NFC, but also the applications for it. So this is very timely and interesting, these developments in the NFC and Bluetooth. Yes, so like these are things that I said. I'm just summarizing here in this picture, which you will have in the video and can take a picture. The pros and cons of each technology, which are discussed in the paper, some limitations. We're also thinking, should we develop it, make it an IFC-based workflow, database and API, further automation of this, and also using more technologies would require more effort, but in some cases, when there's a certain panel that has a certain cavity, maybe there's no need to use 3 technologies, but 1 or 2 would be sufficient. So this is a kind of explorative way of using these technologies to cover the whole life cycle. And of course, if we want to keep things forever, we should carve them into runestone like Vikings did. And there's no 100% certainty and reliability on technologies, like, for example, in these QR codes that have been washed out over less than a year. So thank you, and we are doing some further work, and stay tuned.